Hello everyone, welcome to this presentation of this video to demonstrate this project to develop a machine learning model to solve the problem where we'll be predicting an outcome and analyzing the performance. This course is meant to be for Duke University, and the name of the course is Machine Learning Foundation for Product Managers. My name is Santo, and today is September 1st. This course is time boxed within 5 minutes. We'll try to speed up and then go through each of the slides with the details. And also I used Excel and Google AutoML to reproduce the machine learning terminology and then try to analyze and scale the performance to choose a model which will be our final. So saying that, I'm going to the next slide, where we will be uh, we'll be looking into our data source. So in this slide, we are showing that the data source from the CSV file where we'll be receiving the value of temperature, ambient pressure, relative humidity, exhaust vacuum, and then also we have the PE with a range of 420.26 to 495.76, which is our main target, and then that will be used for the prediction. So in the next slide, we are setting some goals for this project where we'll set the define approach, possible feature. From the column we have the four columns where we have the PE value, and then the rest of them are, as we mentioned, the AT, AP, RH, and the vacuum V values. So that will be our inputs, and then we have to get the output to analyze the performance. So moving to the next slide, and before that, the comparison we'll be doing for different models to get the data, and then we'll set a which model we'll be choosing, and then fit for this specific goal. So we went through the data and then planned for four different scattered data set used for four different graph, and then where we see that scattered data set is showing that multiple r square and different values, where if we focus on the values, we'll see that there are some similarities between multiple r's, and that for the PE versus AT, where the multiple R is 0.9, which is close less than 1, and then close to the range. Moving to the next slide. So here we analyzed different modules, and in the next slide actually we'll be seeing that the module we choose to analyze and do the comparison between PE and different data set. The different data sets, when we are saying, is compared to between PE and APRHV versus PE APRH and PE APV. So that's the comparison we did, and in this data set we are seeing that all of the R square are comparatively similar: 0.92, 0.91, and 0.91 for both all three of the models. Jumping to the next slide, where the model selection will be doing that the model we are choosing here is multiple linear regression test, and we are using three different set of test criteria, where we are planning to get the root mean square RMSE. To do that, I use Google AutoML, and I'm going to quickly show the value I got from the analysis, and then after I trained the model with the data, I got the value. The target column was PE. The MAE was 2.56. MAP is half of that, 0.56. So this is like the MAP value is like we got the range from 0% to 100%. So 0.56 to give us like a correct view. RMC is 3.29, and then one of the main thing is the R2 square is 0.9, which is less than 1. So by that we can predict this is like a good module that we'll be choosing, And then one of the thing I would like to add that the AT value is have more impact on this analysis. Going back to the slide to take a quick look on the value that it's showing that R2 R2 the root mean square is less than 1. So the model prediction, the way we are going to choose and summarize, is the performance for all of the models ran accurately with RMSE value 3.299 with a lower MAP. Um, and then the model evaluation output matrix indicates the model output holds the higher accurate data. So we are going to choose this model. And then I think we ran out of time. Thank you so much for watching my video. And thank you.